Hey everyone, welcome back to the channel. I'm Logan, and today we're going to be taking a deep dive into how you can put together your own complete NAS system for in-home streaming and file storage, all while getting the flexibility of deploying it yourself with your own hardware and software setup. But why would you actually want to do something like this? Well, for starters, a lot of NASs on the market right now are really expensive. Even without storage, you could be looking at dropping over $1,000 before you even have hard drives. And that seems like a lot for what essentially boils down to a computer in a very convenient NAS-shaped box. But they do have some genuine benefits in terms of ease of use, especially with the likes of Synology coming out with some pretty robust software that disguises the more complicated parts of configuring your NAS. But for the adventurous among you who might want to save some money and really customize their setup, this could be seen as more of a limitation than an actual feature. Building a DIY NAS is going to be just about the only way to get a reliable and cost-saving upgrade path for your hardware, rather than taking out your drives and throwing out the entire NAS chassis, as would be the case for a regular NAS. And you'll have the freedom to take that hardware out and repurpose it in another computer, which is better for your wallet and better for the environment. And as far as hardware is concerned, there are two essential features that you'll probably want to be looking for in any NAS setup, and the amount of features increases as you get more specific with your use case. But for starters, you'll want to find a platform that offers very low power consumption, as well as hardware acceleration for whatever workload you have in mind that can take advantage of built-in hardware acceleration. Examples of this might be hardware accelerated video encoding built into Intel CPUs through the use of QuickSync video, virtual machine extensions for running VMs with little to no overhead, or an NPU for accelerating local AI tasks on your NAS. And from there, you can widen your search based on what other features you might want to include. For example, a NAS designed for a lot of NVMe SSD storage should go with a CPU and motherboard offering plenty of PCIe lanes, while a NAS built for running tons of heavy containerized services in parallel would be better off focusing on high core counts and memory. I'm going to assume that most people watching a video like this, though, are probably looking for a pretty down-to-earth setup, focusing on getting as much versatility as possible while saving on power consumption and cost. And for those of you out there, I really can't think of anything better than an Intel N100 based setup. These are kind of like the Intel Atom processors of today. They're very widely available, surprisingly fast for embedded CPUs, and boast a TDP of only 6 watts, which is honestly just insane when you compare it to the average desktop CPU that'll happily consume 65 watts under normal load. And there are even some commercially available Intel N100 NASs that just give you the bare essentials, like this Helix unit that I reviewed in a previous video. And these NASs are perfectly fine, but since they use lower quality hardware like unbranded SSDs and RAM, I don't know if they'll have the same longevity as a DIY NAS build. And they certainly don't have the upgradability of a custom build. These are appliances that you use until they quit working or you get something better, and then you pretty much just throw them away. Now, with all that said, if you want to build a reliable NAS system designed for 24/7 operation, I would steer clear of the many pre-built Intel N100 mini PCs on the market right now. While they are very capable devices, and I am more than happy to recommend them for many different use cases, a lot of them usually have serious limitations when it comes to I/O and expansion. While you can add a lot of storage using USB hubs and USB hard drives, or even dedicated USB DAS devices that hold multiple hard drives and make them accessible over a single USB connection, the use of these kinds of storage devices is not recommended by software like TrueNAS due to the possibility of dropouts, which could damage your RAID array. That said, you can get devices like this GMK-Tech NAS that I also reviewed in a previous video. It has an Intel N100 processor and a bunch of PCIe expansion on the bottom, and this would be fine because you're actually connecting your storage directly over PCIe. But you should usually avoid interfaces like USB for mass storage if you can so help it. For this reason, I think it's better to look for a board with a SATA controller connected directly over a PCIe link, as this has been pretty standard on most desktop and server motherboards for the past couple of decades, so stick with what works and you shouldn't run into any problems. A quick example of a very promising looking model is this industrial N100 motherboard off of Amazon. It's a regular mini ITX motherboard that supports any Intel LGA 1150 mounting pattern cooler, and it has pretty much everything you could ask for. DDR5 memory support, 6 SATA ports running off a PCIe SATA controller, 4 2.5 gigabit Ethernet jacks, USB 3, and even display outputs for those Intel integrated graphics. At $189, it's a little more expensive than a similar mini PC, and disclaimer, I've never actually used this motherboard before, I'm just going strictly based on the features, but you would be glad that you chose to get all of the extra expansion options with this kind of a motherboard. If you need more performance, you could widen your horizons and get pretty much any modern desktop motherboard, and I'm more partial to AMD offerings right now since I personally have two 5900Xs that get used daily, and they work great. But even a lower power AM5 chip will offer very good efficiency, and you have the option to set power limits that will keep your NAS running with even less power. Now, as far as a chassis, you also have a few really good options here. Just searching NAS PC case on Amazon will yield plenty of good options, some of which even include hot swappable hard disk bays, just like a real NAS. But I would argue that you should just try to spend as little as possible to get a chassis that will work for your application. While it is really nice to have all these features like hot swappable drives, if you're only doing RAID with 2 hard drives, it's kind of a waste to spend so much more when you can get really affordable mini ITX cases with 2 internal hard drive bays that'll work perfectly fine. Out of the entire service life of your NAS, I can't imagine that you'll spend more than 30 minutes swapping out hard drives, so if you don't need it, don't spend the money. But if you have more drives and start running into drive failures, having quick access to every drive in your storage array can save a lot of headaches. So it's a double-edged sword, and you need to choose whatever works best for you. So to get you started on a potential NAS build, I went ahead and compiled a small list of parts that would work great if you want to build your own reliable N100 NAS that can take up to 2 3.5-inch storage drives. This is a basic build that could be customized and upgraded extensively down the road in order to fit any future use case you might have. This theoretical NAS uses a Thermaltake Core V1 case coming in at $53, and it was chosen for its reasonable price, good airflow management design, and the inclusion of 2 3.5-inch hard drive bays for your storage. That'll get paired with the Intel N100 industrial motherboard that I mentioned earlier at $189 US, and add on a 16GB Corsair DDR5 SODIMM module for $41 to fill that single RAM slot. To cool the CPU, I chose something extremely overkill for an Intel N100. This Thermalright Peerless Assassin 120 Mini is a $37 compact version of the excellent Thermalright Peerless Assassin cooler that I use to cool the Ryzen 5900X in my editing PC. So I don't think you'll run into any thermal issues with this combo, but this is also a place where you could save a few bucks and get an even cheaper CPU cooler if you so desired. Next, we'll be getting a Thermaltake Smart BM3 650-watt power supply. At $65, it's also way overspec'd for this build, but the idea is you can use this power supply and that CPU cooler on much higher-end hardware if you want to upgrade. And finally, the crucial P3 500GB M.2 NVMe SSD is a pretty basic SSD. You could spend more here and get a 1TB drive or get a faster PCIe Gen 4 or 5 drive. But at $44, it gets the job done and leaves us with a total cost of $429. Now that $429 price point is pretty average, or perhaps just a little higher than most N100 NAS setups on the market without hard drives. But again, the killer feature here is the ability to upgrade. You could throw a motherboard in here with a modest AMD CPU and throw in a GPU for a few $100s more, and suddenly you're going to blow away basically every big box NAS available on the market. And you don't have to throw away your case, cooler, power supply, or NVMe drive to do it, and you can still reuse that old motherboard and memory very easily in some other desktop PC case, for example. And next, you're going to have to figure out just how much storage you need and how many drives you want to get. This is going to account for the bulk of the cost of your NAS if you want to get a decent amount of storage, and goes up exponentially if you want to secure your array with more hard drives for more redundancy. If you were building the NAS I suggested in the last section, that would leave you with 2 hard drive bays to populate with drives, and this is enough for a mirrored RAID setup where the contents of your storage array is mirrored across both hard drives. That way, if a single drive fails, you can just remove the failed drive, install a new drive, and rebuild the array. For most folks, this is probably perfectly fine unless you have massive storage requirements. But understanding your storage requirements is also a very important part. For example, across all of the storage we currently have in our network, we're using about 36 terabytes out of 90 terabytes available after formatting. but that includes hundreds of uncompressed 4K UHD Blu-ray movie rips, thousands of video clips we've taken for our YouTube channels, software, backups, and more. But if you want to build a media server, for example, and you take the time to re-encode those massive 4K Blu-ray rips using a piece of software like Handbrake, you can get the average 4K movie down from maybe 65 gigabytes to as little as 10 or 15, while still retaining great quality with modern software AV1 encoding. And this can save you thousands of dollars on hard drives in the long run, but it also costs more time and electricity to do that kind of encoding. The other issue with buying hard drives is that drive prices change all the time, so while I can't really make a recommendation here for what you should buy, I can suggest that you head on over to diskprices.com and mess around with the filters to try to find the drive with the best price per terabyte that's big enough for your use case. For example, I configured it to only show new internal 3.5-inch hard drives and went down the list until I found this 14TB Western Digital UltraStar drive listed at $237 at the time of making this video. So if you bought two of these, you would have 14 terabytes of redundant storage that can withstand one drive failure for $474 US. Choosing a manufacturer is an exercise left up to the viewer. We personally have a mix of Seagate, Western Digital, and HGST hard drives in our storage arrays, and some people absolutely swear by these companies, while others would never give them a single penny. So I think it's worth doing the research to find a reliable drive in your price range to make sure your data is as safe as possible. Figuring out and configuring the right software solution for your NAS can simultaneously be the easiest and most difficult part of your entire setup, depending on what exactly you want to do with your NAS. And there are so many options that I couldn't possibly hope to demonstrate all of them in this video. But this is also the crown jewel of building something yourself rather than buying a big box NAS. If you have an x86 based motherboard like the Intel N100 motherboard that I mentioned earlier, there aren't any limits really. For NASs, Linux is usually a popular recommendation, or if you want to be even more specific, there are plenty of NAS-oriented Linux and BSD-based operating systems that you can use. TrueNAS is BSD-based and offers a lot of customization meant for large-scale NAS deployments, but that might be a little bit too much for a standard home NAS where we might not want to deal with all the enterprise-grade security features getting in the way of a lot of otherwise very basic tasks. But I'd like to take the opportunity here to buck the trend just a little bit and suggest something different. Since our NAS we're building here is really just a regular PC, well, nothing is really stopping us from just loading a completely bog standard copy of Windows and setting it up to run like a server. Okay, let me try to explain the thought process here. Look, I've been a Linux fanboy for the past few years now, and I run Linux on just about everything, from Fedora Workstation on my desktop, to CachyOS on my laptop, to SteamOS on my Steam Deck, to Debian on some various NASs, and probably a lot more than that. But as any Linux user would be well aware of, the amount of flexibility you get with deploying your favorite distro comes at the cost of a lot of complexity. My point being, if you think that's a fun time and you just want to use a Linux OS for your server, go right ahead. But we shouldn't be afraid to put our own personal use case and requirements first, and if you've never used Linux before, it can sound kind of intimidating. So in that case, there's really no reason to avoid using Windows. It's going to perform perfectly fine these days, and setup is going to be extremely easy for a wide range of different use cases. For this video, I'm going to be trying to use a copy of Windows 11 Enterprise LTSC. Now, you can just use a regular Home or Pro version of Windows and they'll work perfectly fine, but what's nice about the LTSC versions is that you won't be receiving any future updates later down the road, which kind of sounds like a bad thing at first. You'd think you'd want more updates, but what this really means is that it will remain on the stable 2.4H2 build of Windows 11 while only receiving critical security updates, meaning better uptime for your NAS and even less bloat. I can't tell you where to get this particular version of Windows, but a little Googling can go a very long way. So with all that out of the way, let's talk about the basic setup here, and then we'll get on to adding extra software for other NAS tasks like in-home streaming, file sharing, and a whole lot more. And to get this started, you're going to need to get a Windows installer created, and the easiest way to do this is probably by using the Windows Media Creation tool on another PC, which you can just go ahead and download from Microsoft's website. I'd recommend just to go into Google here, and you can type in Windows 11 Media Creation tool. You'll get two results here. Go to the second one to download Windows 11, and just scroll down on this page until you find the section to create Windows 11 installation media. Go ahead and download that and open it, and Windows Media Creation Tool will start getting everything ready so you can go ahead and make a Windows installer. Basically, just click through all of these menus as they come up. Same thing here. And now you need to get your USB drive ready. This should be at least 8 GB in capacity, and I'm just going to plug it in right now. And go on. You can see right here my USB drive is showing up as drive D, so I'm going to go ahead and go next. And Media Creation Tool is going to start downloading Windows 11 and copying that to your USB drive. And if you have an ISO file for Windows like I do here, you can just go ahead and open a web browser and search for a tool called Rufus online, which you can use to flash USB drives without using the official Microsoft utility. Just go ahead and scroll down until you see the download link. Ignore this right here. And you can see right here, Rufus is now downloaded. And you can see my USB drive is showing up right there. I have the option to select an ISO image, which I'm just going to go to my desktop, and you can see it right there. I'm going to open that image. And if everything looks good, you can just go ahead and start. It's going to ask you a couple of questions if you want to change how the Windows installation is set up. You can see here, it's going to destroy all the data on the drive. I hit OK. It can't really get any easier than that. And to demonstrate all of this, I'm actually going to be using that Helix NAS that I alluded to earlier. Right now it has a 1TB NVMe SSD and 16GB of DDR5 memory, which is pretty representative of what I think most people would be running this kind of low power NAS with nowadays. And in order to set it up, I'm going to hook up a display, keyboard and mouse, and that USB drive that I flashed with a Windows installer. After that, just turn on your server, and the first thing you'll need to do is figure out what key you use to get to the UEFI boot menu. If you bought a motherboard, you can check the manual, but generally this is a key like F11, F12, delete, or escape, and hitting that key repeatedly at boot should hopefully give you a menu that allows you to boot from your USB drive. And once you boot from that USB drive, you should get brought into a Windows setup screen like this. And generally, this is a very easy process. Just click through the menu, agree to wipe your data from your solid state drive, and setup should automatically reboot your NAS once it's ready. Now here's a quick pro tip. Don't plug in your Ethernet cable just yet until you finish setup and get to the desktop. That way you can actually skip adding a Microsoft account and all the forced updates that Windows would make you do otherwise. Just click through the menus, and when it prompts you for an internet connection, just click the button that says I don't have internet. Then you can make a user account for the server, and you should actually secure this with a password since we'll be using this account to remotely access files over the NAS, and you need a password in order to make that work. And now that we're at the desktop, we can actually connect to the internet, head on over to Windows Update, and start installing all of our updates there. And while that's going, let's start getting our storage configured. Windows 11 actually makes this very easy to do. You can create storage spaces and share them on the network using the Settings app. So we're going to go there. Head on over to System, select Storage, and then go into Advanced Storage Settings and click Storage Spaces. From here, you can simply add a new storage pool, and it'll ask you what drives you want to add to the pool, so I'm just going to be using my two 4TB hard drives I have installed in the NAS. Now you can actually configure the RAID layout using the pool size option under Size and Resiliency. For this, since I have two hard drives, I'm going to be using a two-way mirror, which means both hard drives will have the same data contained on them, and I can withstand a single drive failure in the event that anything goes wrong. But choose whatever option best fits the amount of drives that you have and your risk tolerance. Finally, you can hit Create, set a volume label if you want, assign the pool to a drive letter, and choose the file system format, which I just chose NTFS since it's very stable on Windows and pretty much universally compatible. Finally, click the button to format the storage pool, and you're good to go. You should now see a new drive in File Explorer, which represents the total size you have available across your entire storage pool, and this is where you'll be configuring your network share. So go ahead and right-click on that drive, go to Properties, and enter the Sharing tab. Click the Advanced Sharing button, which will open another window, and you can check the box to share this folder. And now you'll want to go into Permissions, and what I'm going to do here is add the user account that I made during the Windows setup to this access list by clicking add and typing the username in the new window that appears. If you click verify name, it should format the name with the host name of our server in front of it, followed by a backslash, and that means we're good to click OK. Now we need to give our user access to the share over the network, and this is pretty easy as well. Just click the user in the usernames box, and then in the permissions checklist below, I'm going to allow full control for my user. Now just hit apply and OK again in the box below, and just like that, we have turned our storage pool into a network share that you can connect to from any other client on the network. So I went ahead and tested this on another Windows PC by opening File Explorer, and I just right-clicked on this PC, click the button that says Map Network Drive. This will show you a dialog that you'll need to type the address to your share into, which you can do by typing 2 backslashes, then the host name of the server, followed by another backslash, and then the name of the storage pool you shared. And if you don't know the host name of your server yet, you can check by going back to the server and just open the settings app, where your host name will be displayed right at the top. If you want, you can also change this, but for now I'll just leave it as is. And once you've connected to that share, you can now copy files to and from your NAS without actually being in front of the NAS. But at this point, I am going to make a couple of recommendations to make this more suitable for server use, like for example, configuring your power and sleep settings to disable automatic sleep after a short period of time, because you don't want to be waking your server up all the time in order to use it. At this point, installing other server software like Jellyfin is very simple. Just go to Jellyfin's website and download the server executable for Windows, run it, and you should be able to configure your server just like normal. There are already plenty of guides out there for this process online, so I think it's just a little outside the scope of this video, but it's pretty easy, and we've even made our own guide in the past. So, with all that said, I think I've done just about everything I can to hopefully get you up and running with a small, power-efficient, and easy-to-use in-home server setup. And I'd like to know down in the comments section whether or not this whole process is honestly something that you could see yourself doing in your own home. If you thought this video was helpful, don't forget to like, subscribe, and ring the bell so you don't miss any of our future content. And as always, have an awesome day.